Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 13, 2026, about 3 days ago. It introduces a massive new benchmark containing over 37,000 queries, which reveals that even state-of-the-art retrieval models struggle significantly when spoken questions are mixed with realistic environmental noise. The paper is titled SQuTR, a robustness benchmark for spoken query to text retrieval under acoustic noise. And as we'll see later, the results highlight a major gap in reliability for modern voice search systems. And for those interested in the implementation, the authors have shared their code on GitHub. So to build this benchmark, the team aggregated data from 6 established sources, listed here in Table 1. The first 3 rows display the English datasets: NQ, HotPotQA, and PhiQA, which focus on Wikipedia and finance. Moving down, the remaining rows cover Chinese sources like Do Retrieval and Medical Retrieval, adding encyclopedia and medical queries to the mix. A look at the corpus column reveals massive scale differences, ranging from over 5 million documents for HotPotQA to roughly 58,000 for the finance dataset, ensuring the system faces varied retrieval challenges. With the datasets established, Table 2 details the acoustic interference added to these queries. The framework tests 4 conditions, starting with a clean baseline shown in the first row. As we move down, it introduces low, medium, and high noise levels by adjusting the signal-to-noise ratio. Crucially, the high noise setting at the bottom drops to 0 decibels, which means the background noise is technically as loud as the speech signal itself. Figure 1 maps out the entire workflow for creating and evaluating the benchmark. In the top center, Panel B shows how text queries are converted into speech using Cozy Voice 3, drawing from 200 diverse speaker profiles to capture different accents and ages. To ensure accuracy, Panel C on the right details a quality control step where the generated audio is filtered using Whisper Large v3 and human validation. Finally, Panel F at the bottom right establishes the testing framework, comparing traditional cascaded systems against end-to-end models that process audio directly. Alright, while the previous table defined the noise intensity, Figure 2 details the specific environmental sounds injected into the queries. These 6 panels correspond to the source datasets, and the x-axis on each plot lists 16 distinct environments, ranging from kitchen and park to traffic and metro. You can see that the bar heights within each chart are quite uniform. This balanced distribution ensures the benchmark tests robustness across a wide variety of real-world scenarios, rather than overfitting to just one type of background noise like office chatter. Moving to the results, Figure 3 visualizes the trade-off between accuracy and stability. The vertical axis shows the mean score, while the horizontal axis tracks standard deviation, essentially how much performance fluctuates under noise. The purple dot for BM25 at the bottom left confirms that while lexical matching is very stable, it lacks the accuracy of modern systems. Conversely, the large blue bubbles at the top, representing the QN3 models, achieve the best scores but sit further right, indicating higher sensitivity to interference. However, looking closely at the blue cluster shows that larger models are actually more stable than their smaller counterparts. Table 5 provides the hard numbers, detailing performance across both Chinese and English datasets. The columns track retrieval quality from clean speech on the left to high-intensity noise on the right, focusing on the dense QN3 series near the bottom, specifically the 8B model. It achieves the highest scores, yet its accuracy in the Chinese section still dips from roughly 0.78 to 0.73 as noise hits the maximum level. In contrast, the end-to-end systems row at the very bottom shows the Omni-Embed model lagging behind, scoring only about 0.57 under high noise. This confirms that a robust cascaded approach remains superior to processing raw audio directly. So wrapping up, SQuTR proves that acoustic robustness is still a major hurdle for voice search. The main takeaway is that even massive models degrade quickly in noisy environments like subways or kitchens, highlighting a need for better integration between speech processing and text retrieval. Hopefully this standardized testbed will help close that gap. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.